Hello, my name's Craig Gallen, and I wanted to give you a brief introduction to the OpenNMS Pax Exam testing framework, which has been developed to help with integration testing of plugins within OpenNMS. This work is still quite experimental, but I think it provides a useful starting point and would really appreciate any feedback you can provide for the project. Links for the project are included in this video, and you should be able to spin up the whole thing yourself fairly easily following instructions. So, what is Pax Exam? Well, if we looked at this diagram, we can see that Pax Exam basically allows you to spin up a test container which contains karaf, and then allows you to put your own program into karaf and then deploy what it calls a test probe into your container, which will actually run JUnit tests against your bundle. Now, in normal operation, the way this works is that you annotate your JUnit test with this run with Pax Exam class, give it a bit of extra information as to the configuration of your karaf, and Pax Exam will download karaf, unpack it, put the configuration in that you have requested to be applied, and then spin up karaf, install the bundles you need to run in karaf, and then run the test. And the test itself will be injected, as you can see here, as a test probe into the OSGI container, and then it will run locally within karaf and give you the results back. Now that's very, very useful and has been used by lots of projects for testing OSGI applications. But the problem is that if you've got karaf in an embedded application, where there are lots of other services that wouldn't normally be running within karaf, then it doesn't necessarily provide you an accurate or useful test environment. So the motivation for this project is, as we can see in this next diagram, is to allow us to run up a complete OpenNMS system with its Kafka bus, PostgreSQL, its minions, and anything else that might be part of the system within a Docker Compose project. And then, having spun up that standard OpenNMS install, we can inject the plugin that we are developing, and we can also inject the integration tests as test probes into that running OpenNMS. Now, this allows us to actually test against a real running application, rather than basically trying to set up the equivalent of that application through Pax Exam configuration. So what we do is we effectively run OpenNMS. OpenNMS has got its own daemon services which are exposed through OSGI to the test probe. The test probe can basically activate or use any of the services that OpenNMS normally provides, and we can also cause our application to be installed as either a car or as a feature on top of the installation, and OpenNMS will actually run the tests and you'll get results back based on that. So that's the basic principle. What I want to do now is show you it working in practice. So if I show you the actual project that we're working on, which you can see here, we have a test example, and I have a number of tests, two tests actually. This very first test is very simple. All it does is it basically uses the Pax Exam class to activate Pax Exam. It gives it our OpenNMS plugin test container factory, which has been developed to allow this test to work. And then that factory is given this information. We're going to run against localhost, and we're going to use RMI port 55555 to actually inject the test bundle into our running karaf container. And you can see that what the actual tests are doing is they're just printing out to the logs some information that you can see here. Now we have another test, this command test, which actually executes a command within karaf. So just as you would run a command within the SSH terminal, you could run this command directly within your test and get the result back. The execute command actually sends back a string which will then actually be pushed out as part of the log message that comes out of this test. And you could put in any standard karaf command here. So you could tell the karaf container to load up your bundles, for instance, or load up your feature, and it would do that. And you could do that as a precondition to your actual test, and then your test can actually act against the underlying information. Now, this particular example of test actually builds on top of this test base, which I can show you here. And you can see in this case, the test base has got the configuration we mentioned earlier. We're going to run against localhost port 5555. We've got this wait for RBC, which just means it's going to wait up to 10 seconds for the whole thing to start up. And then it's got various different things that have been injected. So in this case, we're injecting the bundle context, we're injecting the feature service, and we're also injecting the session factory. Now the session factory is actually what is used to run the command. So you can see further down that this particular example has got some classes to actually run the command for us and give us the result. But that's basically the basis of how it works. We can inject services that the OSGI container provides, and then we run against those services that command. Okay, so we have two tests, this command test, and we have this very, very simple test here, which just prints out log messages. How do we get it to work? Well, the first thing we have to do is we have to actually compile the project that actually provides all of these Pax Exam classes that we need. Now, in the future, these jars that we're compiling will actually be provided hopefully up in a Maven repository, so that you don't need to do this compile step. But for now, we haven't done that. You've got to compile it and install it locally. So Maven clean install, standard command you do to actually build these various parts of the project. And once that's completed, we now have all of these jars available in our local M2 repository. Now the next thing we need to do is we need to import those jars into the right places within our Minimal Horizon project. So this Minimal Horizon project is basically copied from StackPlay. It is an OpenNMS Docker file that and associated configuration that just runs up a Minimal Horizon with its associated database. So I need to do a Maven clean install on this. And what that will do is put the right jars in the right place to be picked up. So that's all we need to do there. And then we need to do a Docker compose start. Docker compose up -d, which will start it up as a daemon. Now it is actually already running. In a lot of cases it'll take a while for this to spin up, but I've already got it running anyway. Now you can see that the actual container is running by looking at the logs against Horizon, and you can see here that that log is complete, that basically that Horizon is running. But what you would probably want to do is watch Horizon starting up before you try to do anything with it. And then you can jump in to the actual Horizon container itself. And by doing that, we use Docker compose exec Horizon bash. That takes us into the container. If I ls that, you can see, this is the actual internals of OpenNMS. And within this container, then I can actually just look at the logs. There we are. Oh, sorry, wrong command. So tail -f karaf log, and that's just showing us the end of the karaf log. It's just where it is in the log at the moment. Okay, so we've got our OpenNMS running. We've installed all the jars that are expected in OpenNMS. If I just show you the project itself, you will see where those jars are. So we're in this Minimal Horizon. Just refresh this. And we can see under the container file system, under OpenNMS overlay, we've got some extra jars we've put into the library. They've been pulled in by this Maven project. And we also have within our OpenNMS deploy directory this Pax Exam feature, which if I open it up, you can see is actually calling in all of the jars that are required for the system to actually start up to be able to accept commands. Okay. So this is basically this Pax Exam feature is what causes OpenNMS to listen on the RMI port for the probe to be able to send in commands. And these jars are necessary in the lib directory in order for RMI to work. I've also got within this some extra information in the config, in the etc directory. In particular, under OpenNMS properties, I have these properties here that are telling the system to run with the host name Horizon with Pax Exam as the name of the actual plugin system, and the RMI port is 5555. And there's also security properties here, which basically say we want to open this thing right up to all incoming commands. This may not be necessary, I have to say, but it's just shown as an example. And I've also modified slightly the Maven config so that down here we can see that what we're actually doing is we're pulling the actual local repository is going to be injected into this share directory, share.m2 repository, and that's what's going to be used to pass our Maven directory, from which is in the host machine, into this OpenNMS system so that it can get access to the jars that you're actually compiling as part of your project. The reason it's been put into the share directory is that when OpenNMS starts up, it looks for all of the jars within its base directory, but it ignores any jars in share. So we don't want it to be scanning this M2 repository at all. We only want it to pick that up as part of any Maven commands that we have. So that's why it's injected there. And if you look at the actual Docker Compose for this example, you can see that under Horizon, we're actually injecting the M2 repository from the local user into that share environment. Okay, so that's how it's set up. We've done our Maven clean install, which actually means that all of these jars are in the right place. Now we can actually run our tests, and we can run them in Eclipse, or we can run them as part of just a standard Maven build. Let me actually just run them in Eclipse. So this first test was, as I showed you, was simply to print out some log information. So if I run that, and we're looking at the karaf log on our right hand side, so we shall run this at this time, run as a JUnit test. We'll see in the console that we're actually creating the default probe and we're injecting it, and we should see on the right hand side that the probe has been invoked. And we can see that we've actually printed out now this message: make sure we can log an error, log info, and log debug, which is exactly what we expect from here. So that test is run, and we can see the test suite is finished, and it's finished successfully. And we've got the log messages we were expecting. So what about the command? Well, the command example, if I go back to the test project, this is it here. We want to just execute this command, bundle list. Okay, so let me run this test. And again, in our local console, we're seeing this happening, but in our OpenNMS log, what we should see is that the probe is going to be installed, and then that command is going to be run. So there we are, that's the command is run. It's quite a long list of bundles within OpenNMS, so that we can see it's given quite a lot of output. But if we go right up to the top, wherever that is, seems to be a long way up, we can see, there we go, trying to run bundle test list command test, trying to run bundle list command test. So that's what we've got here. Then we've got the bundle list here, bundle list, and then the end right down at the bottom. You can see that that the test is completed. There we are. You can run this also as a just a standard Maven command. So if I want to run the tests here in the test example, in this case, Maven clean install. We will see the test running, and on the right hand side, as that test runs, we'll see it's going to actually execute the same tests again. There we go. It's happened. Okay, so just to recap what I've shown you, if I just go back to the diagram, what we have is effectively a way of having a project in Eclipse which builds everything you need for your actual project and puts it into the M2 directory. The local M2 directory is injected into OpenNMS and is used by OpenNMS. You then can run a test, and that test can run karaf commands. The karaf command could be install a feature, and the feature would be installed from your M2 repository. So all of the jars that are being built as part of your plugin, or cars indeed if you had them, would be pulled in from that M2 repository into the running system. Then the tests will be packed up as test probes and will be injected into karaf, and then those tests will be run one at a time, and either success or failure, and all of the logs will be printed out in the overall logging system. And that is running against a complete OpenNMS system that is running in Docker with basically no modification to the core system other than adding these extra classes in to make the testing run. And you can have an arbitrarily complex Docker Compose project. You could include flows or any other features that you wanted within that Docker Compose. Anything really that you can see on Stack Play could be taken in and added into this example. And it would allow you to test the work that you're doing and developing locally and against our OpenNMS distribution, importantly without having to build that distribution yourself. You don't have to build it, you don't have to deploy it, you don't have to package it. You just download using Docker Compose from the OpenNMS Docker registry the components that you need, and then you run plugins against them. And indeed, this could also run against minions, which are essentially also karaf containers. Now, the example I've given you just shows you running a karaf container as a standalone, but that could be a minion, a little bit more configuration required. But in theory, what you could have is a minion and an OpenNMS, and then tests being run against both within an overall environment. Okay, hopefully this has been reasonably good explanation of how the system works, and I hope you have fun, and I really appreciate any feedback you might provide on what has been done here. Thank you very much, and goodbye.